Welcome everyone. My name is Dariel Cruz. I'm from the Dominican Republic. Um, I'm really excited to be here. This is the first time I am having I'm being a speaker at an event like this. I do some things on my own country. For example, this same topic I taught it on a dead fest, on a local dead fest last year. It was a really great experience, and I wanted uh, to share it a bit more. So really excited, and I'm thankful for the opportunity. I hope that we can all learn something new today. So the Q&A will be at the end, but I'll be checking the chat just in case everything, uh, just to make sure everything goes smoothly. So yeah, let's just start. As I mentioned, I'm a developer from the Dominican Republic. Um, so I'm a Christian, I'm a musician, I'm a programmer. I graduated from college a couple of years ago, and I really like working with Android, with AOT, and machine learning related stuff. So the topic, at least the bigger scope of what we're going to talk about today is performance. So performance is defined as the action or process of carrying out or accomplishing an action, task, or function. So it's about doing the things that we want to do, but doing it in a way that optimizes resources and time, space, or whatever, uh, anything else that we want to add to that. So performance is very important for us developers. But rather than just explaining why it's important, I usually like to use like a story that I read about this that I find really useful. It's from a blog called The Codeless Code. It was very popular between developers back in the day. I don't think they are writing it anymore, but I think it was really useful to explain some concepts to developers. So this case is what they call their stories. It's called infinities. It says that two monks were arguing whether the new input validation routine was caught in an infinite loop. So one asks how long has been running, the other answers no more than 30 minutes, but not less either, right there. And you have done nothing this whole time but wait for it to complete. So then the master goes to them and asks them which of them believe the loop is not infinite. So the pelting one says that he believed that. Then he said, give him a skin of wine, for he is wise. No loop may be truly infinite. Someday the power will fail, the server will rust, etc. Then he asked, what of the other one that believes that the loop is infinite? Then give him the two skins of wine, for he is wiser. To the user waiting on his browser, 10 seconds is agony, a minute is an aeon, and anything longer is an eternity. So basically, two monks were arguing whether a loop was infinite or not. So they both had their cases, because one say it's not infinite because the power might run out or the memory, but the other says, well, it's infinite because to the user, even a small amount of time can be um, an infinite minute for them. So why is performance important? Using the example from the story before, well, computer resources are limited, and the user patience is limited as well. But I'm sure we all knew about it already. So just to clear that up. So last year, Android, or since the last years, Android have been giving us some tools to measure and improve performance. So their pillars are to inspect our application, to improve the performance of our application, and then to monitor whatever improvement we added to make sure that they are actual improvements of the previous processes. So this would be like the pillars for performance that Android is providing us. So what can we inspect on an Android application? Well, we can inspect the app size, the launch time, speed, the images and videos and the memory that they are taking up, the screen resolution, memory usage, and the networking. All of those are resource consuming, and therefore they can be optimized, they can be improved. So how to inspect? The same Android documentation provide or shares three ways we can inspect our application: basic, manual, and automated. So the first one is basic. We don't need to write any code or use any tools other than the ones that we have. Just by pay attention to our application, to the runtime, to the waiting times, the loading times, we can check whether there are parts of our application that need to be improved. And if we are using Android Studio, we can use the logcat to check for jank times and other stuff. So that's like the passive way. The manual way will be to use the profiler, to check for network or memory, CPU consumption, and to write benchmarks tests. So now we are getting more into the tools that Android has provided in the last couple of years. The Android profiler, I'm sure many of us are familiar with it. We can use it to check memory, network, energy consumption, and such. So a benchmark, some developers are also familiar with this concept. Uh, Basically, is the process of measuring products, measuring how a process is being done in order to see if we can optimize it. So for us programmers, sometimes or sometime in the past, in order to benchmark some functions or some code that we wrote. For example, some common case is to check the performance of an array list versus a linked list in a language like Java, for example. Uh, we'll just use like a brute force approach. Just check the time before we execute the code, and check the time after, and then get the difference, and that will tell us which one is faster. That's like the classic way of doing it. With Kotlin, since we have first order functions, we have lambda, we can use the measure time and actually just use the code that we want to execute in a block. So it will give us the in seconds or in any other direction that we want the seconds. It's basically the same, but leveraging the features that Kotlin provides us to make it more readable. So, but it's basically the same. We are just taking the time at the beginning and the time at the end and getting the difference. So we can use this, as I mentioned, to measure functions or processes, or we can use it to measure events, like some classic web events on Change, on Click. We also have some mobile-based events that we can use, or we can use the life cycle of our Android application, whether we start something on create and we want to see what is the duration from an activity or a fragment to be on resume. So we can use that kind of measurement method, or we could use that in the past. We could use that today, but I will share something that is more useful for us. So now the automated approach to measuring things in Android. They provided two libraries that help us with all of the things that I mentioned, which are macro benchmark and micro benchmark. So what are the difference between both of them? So the macro benchmark library is for testing larger use cases, including UI manipulations. So a simple way of doing this is it's like an automated UI automated test that will measure the performance on a series of UI steps. That's what we can do with macro benchmark. So in order to create a macro benchmark, and in order to use baseline profiles, we need macro benchmark first. That's why I started with this. So uh, we add macro benchmark as a new module on our Android application. Um, we just create a new module and we select the option here. There is a benchmark, and then we select the module type. If we want to be a macro benchmark or a micro benchmark. Um, so we um, modify the manifest to make it profilable, and then in our app Gradle and our app build Gradle file, we add another flavor with the benchmark um, that we just created, and after that we just create test cases like type of code. We can create a class on the new module that we added, and then we add the test because we run them like they are test cases. So we use the benchmark rule, and we specify that we want to measure repeated as it says, and then we have some parameters that we need to fill out. We have the package name for the application or the UI we want to test. We want can add the number of iterations we have, because micro benchmark provides you with the facility to run a process a couple or a number of times, in case maybe in one scenario gives you a very quick or a very slow time, but it's not like the mean or the average. So that's why we can use we can specify the number of iterations. We have the metrics that we want. In this case, we have the frame timing metric, but we also can use the startup metrics such. We have startup mode, um, that basically we are telling what we want to, or how we want to measure our activity. If it's a cold start, meaning that the activity was not on memory before, is a fresh start, a fresh install. If it's warm, meaning that maybe it was stopped, or if it's hot, meaning that maybe the activity was just paused or in the background, and it should come quickly to the to the front of the screen. So we can specify that as well in the startup mode. Then we can use the setup block to add interactions that we don't want to measure. For example, if I just want to focus on scrolling through a list, which is a very basic example, we don't want to measure like the old activity coming to the front screen or the user navigating to some path. We just want to measure the scrolling. So we use the setup block to do like the pre-configuration, it could be. And then we, on the other block, will be the block that is going to be measured. We add the interactions. Um, for the code, we use UI Automator in order to automate the list. I mean, the list, not the steps of the application that we want. So yeah, for example, we have some methods like start activity and wait on the setup block, and then on the measure block we find a recycler view using UI Automator. We scroll the recycle view and we repeat the scroll. For example, here we have 3 times, and it will run like an UI test, and then it will give you some results. It will give you the time to full display, time to initial display, and it will give you the maximum, the minimum, and the median. As I mentioned, that's why we have iterations, just to make sure that we can get an average of the process, not only like an outer scenario or a peak case scenario. So that's what macro benchmark is for. A micro benchmark is a library for measuring performance as well. The difference is that you can use it to test or to measure Java or Kotlin Android native code from within Android Studio. So it's similar in some sense, but the difference is that we don't use micro benchmark for UI tests. We just use it for um, Kotlin or Android code that we want to measure. For example, if we're doing some complex calculations or mapping some values and we want to test how they perform, then we use a micro benchmark. That's the code. As I mentioned, it's very similar. We use the benchmark rule, and we just on the block we call the method or the code that we want to measure. So all of this bring us to the main topic of this talk: sharp baseline profiles. Well, what are them? Well, they help improve the app starter at runtime experience of Android applications. How they do it? Well, they ship the baseline profile to the Android runtime, and then we can use precompile the code that we added to the profile or the code that is contained on the profiles. And with the profile guided optimization, then we can optimize startup, reduce jank, and improve runtime performance for end users. I know this can sound a little bit like daunting to some people. It was for me at first, but it's actually an easy tool, and what it does is really easy as well. I'll go into some detail right away. So how does baseline profile works? Well, a little bit of history of how Android compile and run APKs. Uh, First, we got the Dalvik runtime, which provided the famous JIT, the just-in-time compilation, meaning that the code that we were going to use for the APK was compiled at runtime. Because earlier in the day, the thing that Dalvik was more preoccupied on optimizing with RAM usage. So with just-in-time compilation, or the people that developed Dalvik and Android apps knew that with just-in-time compilations, it will improve in the performance of the RAM memory, which was limited at the time. But then uh, they switched to ART, or the Android runtime as we know it today, which use ahead of time compilation, or AOT. It means that before running the app, uh, the code is precompiled, or all the paths of the code are precompiled, and they are shipped into the APK, and then the .dex files or the .odex file, or all of them are precompiled, so that they don't compile when the app uh, is being interpreted. So um, each one of these cause some problems of its own. For example, if in the just-in-time compilation, well, we just had the application as it is. We didn't have the option like do some precompile stuff. But if we use ahead of time compilation, if our code is big, if the odex files became really big, then we will actually suffer a lot more, because the space that the application is using will be bigger. So now we have, or Android have, like a mix. Most of the code is compiled to machine code using just-in-time compilation, but we also have the option to do ahead of time compilation for machine code for specific um, paths or features of our code. So basically, we do a trade-off, similarly to what we do in some, for example, algorithms. That if we want to an algorithm to perform better on time complexity, we can sacrifice a little bit of space complexity, and for example, an algorithm that runs in n square time and O1 space, we can make it run on 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 both, and it will be a huge improvement. But uh, if the space we use is actually bigger, or we are um, taking up a lot of space, then it's not convenient for us to follow this approach. That's why Android is following now this mixed kind of uh, approach to the just-in-time and ahead of time compilation. Another good thing is that we now have the profiles on the cloud, the cloud profiler. So when an app is shipped to the Play Store, the user, depending on the usage of the app, can create profiles, or not can create profiles, but can, depending on which path as are the most used, the the Android core profile will take that into consideration, and then it will also optimize those paths. So with baseline profiles, what we have is that the developers have the option to specify those paths to improve, or to pre-compile, yes, to do ahead of time compilation. So we create a profile. We basically write code that basically what is going to say to the ART is, these are the most used paths on my application. For example, the an user login, or an user scrolling down, or seeing the details of a list. Those are the most used paths or flows of my application. So I want the code related to those paths to be precompiled. So that time that the in that case, the speed of the application when going through those paths will gradually improve. And it's been tested that it can take, or that it can better the performance by 30 or 40% of the time that it was initially um, run without baseline profiles. So now we go into the actual code. So what we have to do to add a baseline profile to our application? Well, first thing, as I mentioned, is that we use the benchmark module. So uh, we create we talk about this on a previous step. So that's actually needed because the baseline profiles run in the baseline in the benchmark module. So we need that, and we need to disable the obfuscation of the code in the benchmark model, uh, because of the profile that we're going to generate. So that's the first thing we want to do. We create a benchmark rules that profile, and we just write don't obfuscate there. Then we get this file into the benchmark flavor of the benchmark Gradle build, and we just use program files and specify the program that we just created, the rule we just created. That's the first setup that we will have to do. Then we actually create our baseline profile. You will notice that the code is very similar to the one we use for benchmark. We have a rule. Uh, the only difference is, in this case, is a baseline profile rule, but is basically the same. We use a test because when we run the test, is that the profile will be generated. We use the baseline profile rule, call it baseline profile, specify the package name, and in the profile block, we specify the code that we want to execute, again, using UI Automator for Android. So we can create benchmark baseline profiles for a different kind of interactions with the UI. For example, here's an example of as an star application. It presses home, meaning that it goes out of an application in case it's open. Then start the activity, find the content, and just wait until there's another content. Wait until a snack collection item within the list is rendered. So it waits for just some elements on the UI to render, and then it finishes. So this is a path that the developer considers it will be one of the most used paths on its application. So that's why he or she created the baseline profile for it. So using the macro benchmark scope, we do something similar to just creating an extension function on the using UI automator to automate the interaction. Similarly, here's a similar example, but this scroll the list. So it does basically something similar, but when it finds the snack list, then um, scroll down and wait for the device to go idle. So basically, uh, it's saying, okay, another common path of my application will be that the user scroll through the list and then just stays there. So all of those extension functions that we created using macro benchmark scope, we can just specify them in the collect baseline profile, and every every path that we use here will then be generated into a profile. So we can do as much as we want, but we always have to uh, keep a mind on that we are actually using space to optimize the performance of our application. So if the profiles we generate are small enough, it, they don't take much space on the application, then it's good because we are not sacrificing much. But if we are um, using like a lot of journeys, a lot of paths, our application is big, and we want just to um, generate an end-to-end kind of flow using a lot of resources, then our profile will be bigger than expected, and we will sacrifice space to gain um, a better performance, which is not ideal, as I mentioned earlier. So that's why it's supposed to be reserved just to the most used paths that we want to optimize into our application. So uh, before we run the test in order to generate the profile, we have to prepare a Gradle managed device, because we are not able to just run them on emulator devices without this. So we use manage virtual device from Gradle to specify the emulator that we want. And since some emulators are rooted devices, then we just need to add this line um, to the benchmark build Gradle in order to tell the Gradle that we are going to use that device to generate the profile. So next thing is to actually run the device. We generate the baseline profile, or um, we just click on run. So we run the test because it runs like an UI test case as well. And when it's done, it will generate a device, a TXT file on the micro benchmark module. We'll have to change the view of Android Studio. If we have Android by default, we will have to change it to project to get access to the build folder, and then outputs, connected benchmark, and you'll see the baseline profile generated.txt. So we actually take this device and we change its name to baseline-prof.txt, and then we add it to the main app module on the same place where the Android manifest is. So that's like the guide. If you should add it in the same path or the same route where the Android manifest is. Then we add this dependency to the app Gradle, and we sync the Gradle files in order to apply the baseline profile into our application. So the last thing to do will be to verify the performance. So in order to do that, we go back to macro benchmark again. So we write a test similar to what we do before, but keeping into consideration that we want to test the same flow that we optimize using benchmark profile. So we create a function, we add the package name, the metric, iterations, but here we have another parameter, which is compilation mode. And this is a very useful parameter because basically the compilation mode will tell um, the compiler how we want to run the benchmark in terms of ahead of time compilation or precompiled files. If we use none, it means that we won't have any precompiled code. So it would run like we don't have the baseline profile. If we use partial, it will precompile the baseline profiles or any other profile that we want or that we have, and then we will use just-in-time compilation for the rest of the code. If we use full, then we'll precompile the whole um, code base for the application. So this is really useful because we can use them to compare which is the better approach, and if uh, we can use it to compare if we are actually taking advantage of using a baseline profile. So here, for example, we then have the results depending on the compilation mode. For example, we have the partial, the full, and none. So we can see here that partial is 720, the median to full display. Full is 755, and none is 818. We can see that the partial mode, that is the one that uses the baseline profiles to precompile that profile, and then the rest of the code is just-in-time compilation, is the better approach in this case. So I recommend always comparing with the tree, because sometimes what we are optimizing, what we are creating a baseline profile of, is not actually the most maybe the best path to optimizing our code. And if we measure, we don't have like to blindly accept that we create a baseline profile, then my application will be better. We actually have to measure if it does any difference, in order to decide what if it's okay, or if I need to use another option. So that would be the result. And I think that will be it for the explanation part of the of the talk. Before proceeding to the Q&A, I will actually I would like to tell that this, as I mentioned earlier, um, we now have a way to improve the performance of our applications. It's relatively easy. Writing the code, getting the txt profile is easy enough, but we shouldn't get carried away with it. We just need to keep measuring, to keep an eye of what are the things that are working on our application, and what are the things that are not working as good as we might have intended. And always use these tools in order to improve the profile. If we see, for example, that our the times that we are getting are not ideal, then we might have to change the approach, or use the baseline profile for another path, or maybe not generate the profile for all the routes or all the paths that I have. That will be ideal in order to fully take advantage of this feature. So all of this, all I talk about, is not of my own understanding. All of this is Android Hub's excellent speakers and excellent documentation about all the performance tools and libraries. I just like took them, and read them and studied them, and wanted to share them uh, with you guys, with some more people. But if you have any doubts, you can write me. You can go to the documentation, which is really thoroughly and really useful. And and yeah, so I think that will be it for the presentation, and now we can go to the Q&A if we have some questions.
Thanks so much, Dariel. Yeah, so it doesn't look like there's any questions in the chat yet, but feel free to drop them in there if anyone has any questions there. Thanks so much for that overview of the baseline profiles. That sounds like a really good way to have sort of an easy approach to improve the performance of your app. So I did have one question that came to my mind during the talk. And I was wondering like how often you might need to generate these profiles again. Like, let's say you generate a profile, and then after some time that screen goes through some changes in your app. Like, when might be a good time to know to regenerate those?
Yeah, definitely. That's a really good question. So the point of baseline profiles is to precompile the most used paths on your application. So um, if you have a profile from some time ago, and as you mentioned, that screen went through some changes. Um, if there's a significant change on the UI, for example, maybe there's another button to click, or maybe another place to go, then it will be recommended to update the profile, because the one that you had before won't take into consideration the new path. So it will precompile the previous path, for example. So, but if the change is something maybe more visual, but the path is the same, maybe the user start, the user click something, the user scroll, then the profile will work uh, the same, because it will precompile the the scenario, um, the code needed for that scenario, even if it's some new code. The only thing will be if there's a change in how uh, the flow goes, then that I will recommend just to update it, and always making sure that with the benchmark profile, the macro benchmark, that is actually helping your performance and not hurting your performance.
Right. Yeah. Yeah. That's a great note there, especially with the verification that you presented. That seems like a great way to make sure things are working as intended. Cool. So looks like there's no other questions in the chat for now. So I guess I just want to thank you again for giving this talk, and thank everyone for coming as well and watching.
Yeah, thank you, Colin, and thank you everyone for watching the presentation. And just I think I left my GitHub. I just recently got Twitter, but yeah, if you have some questions, you can join the Slack for Android Worldwide and ask it there. So yeah, thanks a lot for the opportunity, and hopefully we can talk again later.